We're going to be describing the effects of the four parameters on the graph of an original function if we make all four transformations in one problem, one application. In other words, what happens when y equals f of x is transformed to y equals a f of bracket b bracket x minus h n bracket plus k. And the nature of those nested brackets is important. Okay? I believe I've handed out a formula sheet. Okay. So if we take a minute and look at your formula sheet, this is on here, and I call this the transformations template. But on the left-hand side, you're given the quadratic formula there in case you need to use it, and you will at times. You're given the standard format for window settings. You're given what are called the laws of logarithms, some exponential information, some permutations and combinations at the bottom. But kind of 2/3 of the way down on the left, you're given general form of a transform function. So this is a template that you can refer to, although I would probably say that by the time you do a bit of work with it, you don't need to refer to it. Okay? But it is there if you need to. And what I can tell you, before we get back to the official lesson, is that everything we've learned that A does, and that B does, and that H does, and that K does, still happens. It's just that it all happens. Okay? So it turns out that if you apply the changes that these parameters create to a function in one order, and then you decide to apply them in a different order, very often you get a different result. And it's a little deeper than this, but it's like BEDMAS. So that we are all doing the same thing. We all have the same set of rules. We have decided to do things in a certain order. And I'll tell you right now that the reason why we do them in this certain order is because of the nature of this. If we did them in a different order, this would look different. Okay? It has something to do with this statement. And you don't need to worry about why, but the fact of the matter is the effects of A and B need to be applied or thought of before the effects of H and K. So you have to do A and B first. If I give you a graph and you know A, B, H, and K for what's going to happen to it, you need to apply the stretches and reflections and then look at the resulting graph, and that's the one you're going to translate left, right, up, down. It doesn't matter whether you do A and then B or B and then A. It matters that you do A and B before you do H and K. So, how do you remember that? Well, you'll accidentally remember it or memorize it accidentally. Or you could just say, I'm going to apply things left to right, or I'm going to apply them in alphabetical order. It doesn't matter. Okay? But we need to all do the same thing. Now, I have never seen on a diploma exam something where it asks what would happen if you shifted it and then reflected it. That's potentially something you could be asked, but you would never do that unless you were directed to do that. So, given the graph of y equals f of x, we are asked to sketch y plus 1 equals 3 times f of 2 times x minus 4. Again, can you double check to make sure that that function and that question matches what I have up here in terms of your handout? Okay. So one of the things we can note is, and you're supposed to write the mapping of point P as well, I believe, right? Okay. One thing you can note is we could write g of x plus 1 equals 3 times f of 2 times x minus 4. And I think the key in determining what this graph looks like is identifying the values of those four parameters. I have a typing mistake up here. I believe I have a typing mistake up here. Yep. Who can tell me what's wrong with what's at the top of the screen? Shannon. Should be -1 because I've moved that 1 to the other side. Okay. So if you are writing this down, make sure it says -1. I'd like everybody to take a minute, please, and write down the values of the 4 parameters. You are comparing what's written at the top of the screen to this template. That's all you're doing. You're saying, what is A, what is B, what is H, what is K? While you're doing that, I got to check something. Yeah. So I'm getting for A, 3, B is 2, H is 4, K is -1. Are we in agreement there? Okay. So let's write down in abbreviated form what all of these parameters do. Who can tell me what the parameter A having a value of 3 tells us is going to happen to the graph? What's going to happen because of that 3? Right, 3 times, so by a factor of 3. So every point is going to be stretched away from the x-axis by a factor of 3. And I'm going to abbreviate that by simply writing here, because we're in learning and teaching mode, that. Right? If it were a written response, you'd write, well, since the parameter A is 3, there's a vertical stretch by a factor of 3. Jacob, what does the 2 do?
It's a horizontal stretch by a factor of 1/2.
Perfect. It's a horizontal stretch by a factor of 1/2. Georgia, what is the effect of H being 4 going to have on the graph at some point?
It's going to move horizontally.
How far?
4 times?
4 units?
Yeah.
Which direction?
Right.
Right, correct. Because I didn't write this here, but it is +4. So we're talking here about a move, and I like that you used the word move. You didn't just say 4 to the right. It's a move, or it's a translation, or it's a shift of 4 units to the right. And J. Roos, what is the -1 going to do for K?
Moves the graph 1 down.
1 down. Okay. So 1 unit down. So we have to apply these changes to that function to get a final result. Now I'm presenting this example using 2 different methods. You can certainly do it in 2 steps, meaning I can apply A and B to this original graph, and can you check to see that this matches your original graph? Okay. I can apply A and B to this to draw on this first grid the result of the stretches, and then I can take the result of the stretches and translate it 4 units to the right and 1 down. I think this is overkill. I could have given you more grids, and I could have said, draw this after the vertical stretch by a factor of 3, then draw it after, and I'm talking about cumulatively speaking, take the result of the vertical stretch by a factor of 3 and now stretch that horizontally by a factor of 1/2 and draw it on its own grid, and then take that and draw the result of shifting it 4 to the right on its own grid, and then on another grid, draw it after it's 1 down. I think that's too much work. So we're just going to do the stretches together, and then we'll worry about the translations. So if I start on the left here and I take this original point which is there, and there's a way to do this with mapping that we'll talk about later, and I stretch it vertically by a factor of 3, it's a fact that this point will be up here at 6, at y equals 6, because it was at y equals 2. Now, we're not going to plot it there, because what we need to do now is also stretch that point horizontally by a factor of 1/2. And now we're looking at the fact that it happens to be 6 to the left of the y-axis. 1/2 of 6 is 3. And I'm going to maybe point out to you, and I'm just going to write it off here on the side somewhere and then erase it. If you have more room and you feel you'll get something out of writing this down, by all means. What we have done to get to here is we have taken the x-coordinate and multiplied by 1/2 and the y-coordinate and multiplied by 3. That's the mapping so far. Right? The x-coordinate was -6, and now the x-coordinate is -3. It's been multiplied by 1/2 because that's the vertical stretch factor. The y-coordinate was 2, and now the y-coordinate is 6. It's been multiplied by 3. Right? So that's the mapping. That's what happens first. In fact, in terms of the mapping, you were asked someplace here to write out the mapping, correct? Very bottom of the page. I don't know if I put it up here, but I guess not. I'm going to start the mapping, and you can go ahead and start it as well, by saying that we definitely are taking 1/2 times x, leave some room. And we are definitely taking 3 times y, leave some room. That's a fact. That happens first, before anything else. So that's the first layer of the mapping, if you like. Well, let's get back to the question here. So now I'm going to take the next point that I have kind of indicated by putting a dot on the original graph, and I'm going to stretch that vertically by a factor of 3. Done, right? It doesn't move. And horizontally by a factor of 1/2, and we have a little bit of a problem here, because it happens to be 3 away, and 1/2 of 3 is not an integral amount. It's not an integer. It's a rational number or a fraction. But that's okay. It's going to be -3/2, or -1.5 if you like. And at this point in time, of course, you could connect them. I'm not going to connect them till we have them all there. I hope you understand that shape is a W, and if I make it 3 times taller and 1/2 as wide, it's still going to be a W. We know how it's going to be connected in the end. So now I'm going to go to the next point that I've indicated here, and I'm going to stretch that point vertically by a factor of 3, which is going to put it up here, 3 away from the x-axis, because it's currently, before that stretch, it's currently 1 away. And I'm going to stretch that point horizontally by a factor of 1/2. Well, I've done that. It's done, because it's an invariant point because it's a y-intercept at this point. If I take this point and stretch it vertically by a factor of 3, it doesn't move. Horizontally by a factor of 1/2, it becomes here. Becomes that point there. And finally, this one, vertically by a factor of 3, is going to put it up at 6. Horizontally by a factor of 1/2, we'll put it over here at 3. Sorry, I'm still getting used to my routines with this new bell schedule. I should have handed this out earlier. So what we want to do now is sketch that W. Every time I hand out the rulers, I have fewer than I did the day before. So what does this look like? Well, it looks like a W. It's 3 times as tall and it's 1/2 as wide. Good? Okay. This is just distracting me. I just want to get rid of it. All right. So now what we need to do is apply the parameters h and k. We need to shift that resulting W 4 units to the right and 1 unit down. So I'm actually not a fan of doing this in pieces. I would rather do it in one shot. Because now I have to take this and visually translate it, wrong word, visually apply it over to this second grid and then translate it. So I take this point here, which happens to be at -3, 6, and I need to shift it 3, 4 to the right, and 1 down. Okay. So this point ended up here after the effects of A and B, and then ended up, actually, that's not a very smart move, educationally speaking, ended up here and then ended up here, right? Now, we could continue to do this with all of the other points, or, and this will be very helpful later on in the course, we can recognize that this shape we're looking at in red on the left has to be maintained when I move it to the right. So in my mind, when I look at the distance between the two tops of the ends of the W, they are 6 apart, which tells me that we're going to have the other side of the W 1, 2, 3, 4, 5, 6 away. I could certainly take, this can get a little messy, I can certainly take this point, which became this point, and then take this point at the top at 3, 6 and translate it 4 to the right and 1 down, but I'm going to land here, right? In relation to these two kind of what I'm going to call peaks, the top of the middle of the W is halfway between them and 3 below them. We could certainly translate this point I've got in blue 4 to the right and 1 down. If I do, 1, 2, 3, 4, and 1 down, I discover it's halfway in between and 3 down. So I can plot the remaining points by looking at where they are relative to the other points, or I can translate things. I hope that makes sense. Are you with me on that? Okay. You know, if I use the relational kind of thing, these 2 points are 1.5 away horizontally from that middle point and 3 down. So I could certainly plot them like that. 1.5 and 1, 2, 3 down. 1.5 and 1, 2, 3 down. So if we connect these points, that's the resulting function. That's the answer to the question in terms of what the graph looks like. So let's connect these. I don't think what we're doing here is complicated. But if you're not careful and organized and thoughtful in your work, you're going to make mistakes. You'll make mistakes even if you are careful and organized and thoughtful. So you want to minimize those. Any questions with that method? Yeah.
What's the mapping look like?
We're not done yet. Okay, just getting this graph. We'll talk about the mapping. I mean, I guess I can finish the mapping now. I had said, Eric, that, and you already have, I believe, just so I know if I have to change my note package or not, you already have this typed out for you, right? Okay. So, and what we have said is that since there's a horizontal stretch by a factor of 1/2, the x-coordinates are multiplied by 1/2. And since you've been told you always do stretches first, that's the first thing that happens to x. We're not going to shift in any way. We're just going to multiply x by 1/2. And you know the vertical stretch factor is 3, so y gets multiplied by 3. Now, after you have done this, what did we do to x? Eric, what happened to x after we stretched it horizontally by 1/2?
Moved it 4 units to the right.
So that completes the horizontal mapping. That in this particular case, the mapping is x becomes 1/2 x plus 4. By the way, this looks totally different than what things look like in our function notation at the top of the page, right? That's like 2 brackets x minus 4. This is totally different. And what happens to the y coordinate after we've stretched things vertically by a factor of 3? So that's the mapping. And before we finish this problem off by looking at doing it in one step, really what the mapping is going to be when we have what the mapping is going to be will be 1 over b times x plus h, comma, ay plus k. Always. And by the way, make a note that if there's no stretch, if there's no vertical stretch, a is not 0, a is 1. If there's no vertical translation, k is 0. So that's the mapping for this particular question, and we can use it, and I'm glad you asked, Eric. We can use it to come up with a more general statement about what the mapping will always be. Now, let's finish this off by doing this in what I call one fell swoop, just in one shot. To me, this is easier because, well, to me. Everybody's different, right? So I look at this and I say I need to stretch this vertically by a factor of 3. I need to stretch it horizontally by a factor of 1/2. And now I'm going to shift it 4 to the right and 1 down. 1, 2, 3, 4, 1 down. I'm going to take this point, stretch it vertically by a factor of 3. Well, that's done, right? Because it's invariant vertically in terms of stretches. Horizontally by a factor of 1/2. Shift it 1, 2, 3, 4 down, 4 to the right and 1 down. And when I do this, I might be lightly touching the paper with my pencil. Right? Because if you're doing this on paper, you can't draw a dot and slide it around and move it that way. So, and then I can connect them or wait. I take this point and I stretch it vertically by a factor of 3, horizontally by a factor of 1/2, which is done. And then 1, 2, 3, 4 to the right and 1 down. To me, that's just, well, it's more direct, obviously. To everybody, it should be more direct. We're getting there quicker. But I think, to me, it's easier on the brain. I just have to be organized because I'm keeping 4 things going on at once. Right? So moving on to this one, stretch vertically by a factor of 3, horizontally by 1/2. 1, 2, 3, 4 to the right and 1 down. Take this point, vertically by a factor of 3, horizontally by 1/2. 1, 2, 3, 4, down 1. And you can connect them. Now, if this were a written response question, and it could be partly a written response. I'm not going to connect them. You can connect them. And it asked you to justify the coordinates of these points. I think using mapping is a good thing. You wouldn't have to do it with every point. But let's do it, for example, with this point. -6, 3. You don't have to write this down. But what you would do is you would explain why this is the mapping. Ugh. You would explain why this is the mapping by saying things are stretched horizontally by 1/2, vertically by a factor of 3, then translated 4 to the right and 1 down, and you would map this point. Did I read the coordinates right? -6, 3?
I think it's 2.
-6, 2?
I think it's 2, yeah.
Okay. Thank you. Claire, thank you. And basically, you would put this here, and you would put this here, right? That's an algebraic way for you to communicate on paper. This is what's happening. Otherwise, you have to start getting very wordy and saying, well, if I stretch negative 6 vertically by a factor of 1, or horizontally by a factor of 1/2, it becomes 1/2 times negative 6. It becomes cumbersome. A lot of work that's not necessary. So we would have negative 6 here, and we would have 2 there, and you would figure out what this is. 1/2 times negative 6 is negative 3, plus 4 is 1. 3 times 2 is 6, minus 1 is 5. So hopefully if we look at our graph and you go over to 1, 5, you will discover that that's the sister point of negative 6, 2. 1, 5. But honestly, everybody, what I've done here, I'm teaching you some math here, by the way, but what I've done here, I don't think that's the way what you'd want to do for every point. You're asking for mistakes to happen if you do this. Okay. So any questions with that first example? All right. Example 2. Use the following information to answer the question. Once again, I've changed this lesson considerably, so can you confirm that this is the function given at the top of that page? Okay. And that's f of x. You're not told it's f of x, but you can see it's labeled as f of x. And what you are asked to do is write the equation for g of x in terms of f of x. And I've just put the original over here on the side. That way I don't flip back and forth. So this is A. What's the first thing we want to do? Well, you need to determine A, B, H, and K. All right? So let's start with A. Forget about where this thing is. That has to do with K and H. Is this thing the same height as the original graph? If it is, and it's oriented the same way, then A will be 1. Is it the same height? It's not. So, is this new graph taller than the original? Because if it's taller, A will be a number bigger than 1. No, it's shorter, right? So what's the proportion here? Is it half as tall? If it is half as tall as the original, A will be 1/2. Well, let's figure this out. We're looking here, everybody, at the height. I'm looking at the distance from here to here. That's what I'm interested in. And that has a height of 6. When I look over here, the height can be determined by looking at the distance from there to there. And that's not 6, it's 4. So the question is, what do you multiply 6 by to get 4? And the answer is 2/3. 4 is 2/3 of 6, which tells us that A is 2/3. Okay. A is positive 2/3 because it's oriented the same way. This point here on the original is pointing towards the floor or towards the bottom of the sheet of paper. And on the new one, it's still pointing towards the bottom of the sheet of paper. So A is positive. Now we're going to move our attention to B. And now what we're doing, everybody, is we are looking at how wide this thing is in relation to the width of the original one. And when I take a look at the width of the original one, it's 12. And when I take a look at the width of the new one, it's not 12, it's 9. So we have been stretched horizontally by a number that's smaller than 1. Because to go from 12 to 9, you have to multiply 12 by a number smaller than 1. You have to multiply by 9/12, which is 3/4. Now I'm not going to stand here and teach you how to determine that. That's just a number math skill that you need to have. That 9 is 3/4 of 12. Which means that the horizontal stretch factor is 3/4. Which means that B is 4/3. The reciprocal of the stretch factor is B, or the reciprocal of B is the stretch factor. And ultimately, everybody, we just need to find H and K now and then put A, B, H, and K into the positions in that template. And now you go, how am I going to determine H and K? And there are a number of ways to do it, but I think there's one best way. It's to pick any point on the original function, and I'm going to do this with a few, to pick any point on the original function, to apply the stretches to it, and see what happens. Okay? If I apply the stretches to that point, and it ends up landing here, then there is no horizontal shift or vertical shift. Okay? So, where will it land? Well, I'm going to take this point, which is 4 away. Well, 4 away from the, I'll stick with that point, y-axis, and we're going to stretch it horizontally by a factor of 3/4. And I'm not doing this with mapping and numbers. I'm just saying that it will then land here. Would you agree? Think about that for a second. If I take that point that I've put a brown dot on, that's highlighted in bluish, and I stretch it horizontally by 3/4, which is what happens, it lands on that green dot. Now what I'm going to do is stretch that vertically by 2/3, and it's going to land on this red dot. Because this green dot is 3 above the x-axis, 2/3 of 3 is 2. Yeah?
You put 4/3 for B.
And B is 4/3. So this is what I was talking about yesterday. B is 4/3. B is 4/3. B, the number that goes in the equation, is 4/3. I'm not stuck in an infinite loop here. I'm just repeating myself. Okay? The stretch factor is 3/4. And you may have noticed that when I was about to stretch this horizontally, I stopped and I was thinking. And that's because I had to sort out in my head, which number am I using for the stretch factor? Am I using the 4/3 or the 3/4? So this is tricky. This can be tricky. The horizontal stretch factor is not the parameter that's going to go into the equation. But the horizontal stretch factor is what happens to the points. Is that okay? Is that my phone? Give me 1 second. Okay, so the stretch factor is 3/4. I want to go back here because my thoughts were interrupted. And I need to trace it back to the beginning to make sure you get it. That brown point is an original point on the original function. If I stretch that horizontally by a factor of 3/4, it lands on the green position. And if I stretch it vertically by a factor of 2/3, which we've established is going to happen, it lands in the red position. But we don't want the end, the left side of this function, to be here. Where is it we want it to be? We want it to be here. So the question becomes, how can I get it there? And the answer is, I can shift it 2 to the right and 3 up. I want it to be at -1, 5. This is where I want that point to be. Did I say 1 to the right? I think I said 2 to the right. If I didn't, I meant to. 2 to the right and 3 up. Which tells us that H is 2 and K is 3. It's a messy thing. If it's a written response, it's complicated to communicate that. Let me do this again, though. Because it shouldn't matter which point I decide to think about. So, for example, I might focus my attention on this point. And that might be a wiser move because it's not affected by that horizontal stretch factor. So if I stretch this point vertically, here's the original point, vertically by 2/3, it lands here. And when I stretch it horizontally by 3/4, it doesn't move. Where is it I want that point to be? I want it to be here. I want that point to be there, which is at 2, 5. 2, 5, 2, 5. I want it to be here. Well, how do I do that? I take that red point and I shift it 2 to the right and 3 up. And that's, to me, that's kind of a magical thing, that it doesn't matter which point you choose. You're going to get 2 to the right and 3 up. You could do it with any of those points you like. And there's no simple way around this. You just do it. Okay? So, what's the equation of the function? It's y is equal to, or g of x if you like, is equal to 2/3, that's where a goes. I'm doing this. I'm saying g of x is a f of b bracket x minus h n bracket plus k. I'm putting all of the parameters in here. So g of x is 2/3 f of 4/3. We don't put 3/4 here. We put the parameter. The stretch is not b. Bracket x minus h, n bracket plus k. This is the answer to the question. B. Can you again make sure that B, my graph, matches yours? Okay. So, first things first. Is it just as tall? If it's just as tall, if the new function, which I'm calling k of x here, is the same height, then a is 1. I don't think it is it? Okay. It's taller, so a will be a number greater than 1. The height here, from here to here, is a height of 6. The height from here to here is a height of 9. Pretty sure? 8. It's a height of 8. Well, that's 8/6 times as tall, or 4/3 times as tall. So a is 4/3. Is a negative 4/3 maybe? Well, no, because the point of this graph is towards the floor originally and afterwards. It has been not reflected vertically. However, I hope everybody would agree that there is a horizontal reflection here. This graph, the new graph, is oriented backwards, left-right, compared to the original. So b is negative. And now we have to decide what b is by first determining the horizontal stretch factor. So what we're looking at now is the horizontal width of this graph. Well, the width of the original graph I can see is 12. It's 4 to the left and 8 to the right. That's 12. What is the width over here? Well, it's only 6. So we're talking about a horizontal stretch by a factor of 1/2, which means b is negative 2. Because if the stretch factor is 1/2, we need a 2 in there, which is the reciprocal. How do we determine h and k? Pick a point, apply a and b, and then see what correction needs to be made to put the point where it belongs. So, for example, now this is going to be a little more difficult because you'll notice that the grids are different. Right? They show different parts of the coordinate grid. So, I don't know, it doesn't really matter. I'm going to choose to focus my attention on this point here, the point that I've highlighted in blue. If I stretch that point vertically by 4/3, where does it land? Well, right now it's 3 away. 4/3 of 3 means it's going to land at this red asterisk. I am going to now stretch that horizontally by a factor of 1/2. Done. And I'm going to reflect it horizontally This is why I picked this point. Because I see that the most action happening with A and B is all about B. So if I pick a point where B will not affect the location of the point, in other words, it's going to be invariant regarding B, it makes my life easier. So this is where it lands after A and B. Where do I want it to land? Well, this isn't bad. I want it to land at 1, 1. No, I want it to land at negative 1, 1. I want it to land here. I want it to land here. So I have to shift it 1 to the left and 3 down. And I wouldn't push my luck here. You could confirm it with other points, but we happen to luck out. If you choose some other points, you're going to be landing off the grid somewhere, potentially. So 1 to the left, 3 down. You okay with that? Okay, we put it into the equation. K of x is equal to A, f of b bracket x minus h n bracket plus k is the equation of the function. We have one more example, and you know, I mention very often that there are things we learn that people will stumble on. This is a big deal, this thing in the next question. This is something that I will mention maybe 8, 10 times before we write our exam. I'll mention it the day before the exam. I might even mention it on the morning of the exam. And some of you will still not take it into account. And if I tell you that on the multiple choice numerical response part of the exam there might be 3 questions where this plays a role, you start to lose 3 marks out of 10 or 12, that's a pretty big deal. So I want you to start by looking at, forget about this point, we have some point, we'll come back to that. I want you to look at g of x, and in terms of g of x in the template, I would like everybody to determine the values of a, b, h, and k. So I don't think there's any question. Well, don't take this the wrong way, but if you can't see that A is -4, B is -3, and K is 7, then you got a lot of review to do here. You got to go back and watch this lesson again, or get some extra help somewhere. Are we in agreement on A, B, and K? Okay. Jacob, what's the value of H?
4.
Where do you get the 4 from?
Well, the -3 of b has been multiplied into the x plus h.
Excellent. I'm going to choose to paraphrase what you said by saying we need to factor the -3 out of x minus 12. Of -3x. Let me repeat that. We need to factor the -3 out of -3x plus 12. So we're going to be left with x minus 4. And you can see that h is 4. And that's huge. That set of brackets, that nested set of brackets, is what it is because, well, how can I put it? That template was built based on the order of these things happening in a particular way. And the result of that order is that set of brackets. If you apply this to the equation of a function and you think it's going to be shifted 12 to the left, you're wrong. It's going to be shifted 4 to the right. We can answer the question now, and you can choose mapping as a tool here. I'm not going to. What I'm going to do is take -18, 24, and here's what I'm going to do. I'm going to stretch it vertically by a factor of 4. You should all look at A equals -4 and understand it's a vertical stretch by a factor of 4 and a vertical reflection. So I'm going to take the number 24, I'm going to change it to -24, and I'm going to multiply it by 4. So what I'm getting is -96. I believe, Noah, you're going to just let me know if that's right. Good. -96. I'm going to take the x-coordinate of negative 18, and I'm going to multiply it by negative 1 because there's a horizontal reflection, which will take me to positive 18, and then I'm going to multiply it by a third because b is 3, which means the horizontal stretch is 1/3. And that will give me 6. And because I'm talking and thinking at the same time, I want to just step back and look at that with my own brain and my own private thoughts. It's okay. Now what I'm going to do, so this is just after A and B. This is like us doing a multiple choice question. We're not showing any work here. Now what I'm going to do is I'm going to apply H and K to that. If this point now is shifted 4 to the right, if this point is shifted 4 to the right, the 6 becomes a 10. If this point is shifted 7 up, the negative 96 becomes a negative 89, I think. And that's it, we're done.